Hi everyone, and welcome back to Educator.com. In this mini lesson, we're going to talk about conservation of momentum by doing the first page of the A+ Physics worksheet on conservation of momentum. You can find the link to it down below the video. Taking a look at number 1, we have a 1.2 kilogram block and a 1.8 kilogram block initially at rest on a frictionless horizontal surface. When a compressed spring between the blocks is released, the 1.8 kilogram block moves to the right at 2 meters per second as shown. What is the speed of the 1.2 kilogram block after the spring is released? Well, the way I like to solve these is with momentum tables. So let's call this block A and that one block B. And as we list our objects, we've got A, B, and our total momentum. Up here we'll have our initial momentum, momentum before the collision or event, momentum after. And initially, they're both at rest. So the initial momentum, momentum before for A and B is 0, so the total is 0. Now, after the event, A, well, what do we know? We're looking for the speed of the 1.2 kilogram block after the spring is released. So its momentum after, mass times velocity, will be 1.2 times v, and we're looking for that v. The momentum of B is going to be 2 meters per second times 1.8 kilograms, which is going to be 3.6 kilogram meters per second. So the total momentum after is going to be 1.2 v plus 3.6. Conservation of momentum says that these must be equal. So if 0 equals 1.2 v plus 3.6, that means negative 3.6 equals 1.2 v, or v is equal to negative 3.6 over 1.2. v therefore equals negative 3 meters per second, where that just means the negative is it's in the opposite direction of what we called positive previously. So the correct answer, what's its speed? 3 meters per second. Taking a look at number 2, we have an 8 Which scaled vector best represents the momentum of the system after the masses collide? Well, by conservation of momentum, you must have the same total momentum at any point unless you have an outside force. So if we have a long momentum vector to the right and a little one to the left, when we add them together, we're going to get something like that. That has to be the same after the collision, so I would say our best answer is whatever that length is minus that little length, which is going to be answer 2. Number 6. At the circus, a 100-kilogram clown is fired 15 meters per second from a 500-kilogram cannon. What is the recoil speed of the cannon? All right, well, here we have a clown, a cannon. We'll make our row for total. We've got momentum before and momentum after. Now, initially, the clown is at rest, the cannon is at rest, so our total is at rest. Now, after the event, the clown has a momentum of 100 times 15, or 1,500 kilogram meters per second. The cannon has a momentum of 500 times whatever its velocity is. So our total momentum after the collision is 1,500 plus 500 v. Now, again, using conservation of momentum, we can state that the total momentum before must be equal to the total momentum after. Now, to solve that, if I subtract 1,500 from both sides, negative 1,500 equals 500 v, and divide both sides by 500 to find that v equals negative 3 meters per second, where that just means the cannon is going in the opposite direction of the clown. So what's the recoil speed of the cannon? 3 meters per second. All right, just one more here. A woman with the horizontal velocity v1 jumps off a dock into a stationary boat. After landing in the boat, the woman and the boat move with velocity v2. Compared to velocity v1, velocity 2 must, well, let's think about it. We've got a woman who has a horizontal velocity v1 jumping into a stationary boat. After she lands in the boat, the woman and the boat both move with velocity, with some velocity v2. Well, because the woman initially had some momentum, when she jumps in the boat, the mass goes up. So the velocity must go down by conservation of momentum. So we'll have the same direction, but the velocity must be smaller. So we'll have a smaller magnitude and the same direction. All right, hopefully those went pretty well for you. If they didn't, go back and check out the conservation of momentum lecture. And if they did, terrific. You're in good shape. Let's keep moving on. Thanks so much for your time, everybody. Make it a great day.